good evening from Texas, back for another installment of Meteorology Lab, broadcasting here from the Dallas area, and we're getting back into another stormy weather pattern. You can see the moisture coming up from the south, and one thing I managed to do is get the cameras up and running, so I'll try to do a little bit more of that in the days ahead. And I had probably about 2 minutes to prepare, so you're getting a little bit of that fuzz back there with the chroma key. Anyway, let's head into the charts here and see what's going on. First thing that I do want to show you is something really cool. And it starts with this storm here in the San Angelo area. You can see we've got the supercell just south of Abilene, a little bit northeast of San Angelo, and this formed just northeast of San Angelo right there. And it had a tornado warning out on it earlier, and now they just reissued another one here. So this is for radar indicated rotation. And you can see the storm has kind of an HP-ish structure. It's got this kidney bean shape going on. And if we take a quick look inside the storm, you can see the meso right there. Let me see if I can subtract out the storm motion a little bit, and we'll try to figure out what kind of shear we have on the storm. Looks like we got maybe about 44 out and 42 in, so that's about 80 knots of shear across a couple miles there. So that's going to be in the that's going to pretty much qualify that as a mesocyclone. Don't see much indication of a tornado in that particular storm there. But here's a good image from earlier using the GOES-R data. So here's what we had earlier. This was at about, let's see here. It was about 9 in the morning right there. So San Angelo located right there. You can see a little bit of stratus and straticule all through this area here. A few higher layers out east. So as the day wore on, you can see the stratocumulus started breaking up. And we started developing these cloud streets coming in from the south. But it wasn't really very homogeneous, because if you look just in the north of the town, there's this area with no cloud streets, a little bit more overcast. And if we go a little bit further, you can see there's even a little bit of transverse banding in here. So it looks like we had some sort of front in this area around Ballinger, Coleman, Brady. Maybe kind of a boundary, kind of like this. And out to the west, looks like the dry line right here. So San Angelo found itself in a triple point setup earlier today. And as the day wore on, you can see it just kind of percolated there. And then we see this one tower northeast of town. And it starts bubbling, and you can see it putting out a couple of pieces of debris. This is what we call a turkey tower, because it has the appearance of kind of a turkey neck, and there's the upper part of it. That little piece splits off and drifts downwind. But eventually this storm does get itself together, and it's really trying there. You can see the boundary way down here. And finally, we do get a pretty good anvil. So it looks like we have deep convection at that point. And now the anvil is getting bigger, and you can see a little bit of it overshoot right there. And these are at 5-minute intervals, since this is the GOES-R, GOES 16. And you can see as time goes on, the anvil gets even larger right there. Not a whole lot of back shear on this storm. The updraft is right there. But other than that, it was pretty spectacular there. Now, if we look at the surface data, This is what it looked like about 10 in the morning across Texas. And here's San Angelo right here. Do we pick out that frontal boundary? It's kind of in this area. Not really. It barely shows up, and if I had done the analysis this morning, I might not have found that. But you can see we have the surface cyclone in the Big Spring area. And when you have convergence like this, that's going to bring air mass contrast together. So probably whatever was sitting out here was reinforced as this cyclone progressed through the day. And there's one in the afternoon. Now we're starting to kind of pick out that boundary a little bit. We have 79 there at San Angelo, 73 contrasting sharply with 65 in the Abilene and Stephenville area. So now we've got a boundary here to analyze. Now one other area you can go to keep track of these systems is Texas Tech. They've got a good Mesonet website, and there's a couple of stations here that we don't normally get, like these here and this one. And even here it wasn't really showing that boundary very much, maybe in here a little bit. Then later on, yeah, it started picking up 69-degree temperatures up here, contrasting with 79 there. So, but you can see the development of this mesolow right in this area. And right around here, you can see the winds are kind of cyclonically curved right there. Now, one chart that you can use is it from SPC. This is the convergence and surface vorticity chart. And let's see, this is what it looked like at 9 in the morning. And they're already picking up that little low pressure area around Big Spring. And you can see this lobe extending to the southeast here. So SPC, their automated analysis, definitely picking up on something right in that area. So you can use these charts to kind of clue you in on where to look in more detail with satellite, radar, and surface mesoscale data. So we can see as time went on, that kind of shifted to the southeast. This is about 2 in the afternoon, and then we see that really coming together in the San Angelo area. There's that lobe right there, so that's where our storm of the day developed. And what kind of severe weather did we have with that? Well, last time I looked, it didn't look like very much. Let me reload this page and see what comes up. Just a couple of hail reports there around San Angelo. Apparently no confirmed tornadoes yet. One other tool you can use also is the model data. This is the high-resolution rapid refresh model from 1 p.m. So this might be what you're using when you're chasing. So at 1 p.m., you can see that low right there around San Angelo. And if you watch the wind fields as you scroll this forward with time, you can see them back in this region right here. So backing is going to be a very good indicator of mesolow development to the southwest. So that's a sign that maybe something at the surface is coupling with upper air dynamics there. And that's important because when you have this backed flow here, that's going to curve your hodograph. That's pretty much all that needs to be said there. So that's going to be a good red flag when you're forecasting severe weather. Okay, let's head up to the 500 millibar chart and we'll zoom out and look at the big picture. There's our low pressure area. It hasn't really moved very much, sitting over the Four Corners area. And we find the polar front jet coming deep out of northwest Mexico into the Midland area and into Amarillo like that. And the 250 millibar chart will show a little bit more of that. So there's the polar front jet right there, strongest wind flow at El Paso and Amarillo with about 80 to 90 knots. And maybe a little bit of a indication of subtropical jet. Certainly in Florida here. You can see these winds here, almost 100 knots over the Cape Kennedy area. So subtropical jet down in that area. Okay, before I go too much further, let me make sure that our audio is good and check in with everybody. Andrew says, looks pretty dangerous down there tomorrow. I think, yeah, tomorrow. Yeah, tomorrow is looking kind of worrisome in this area. Mark is here, Greg Kerner is here, Justin Poliam, Ryan Toomey's watching that San Angelo storm. Ron Chalfant is here, Michael Burrell, David Holcomb, Fun with Tech. Michael Burrell, Texas Cell, was reporting 3-inch hail half an hour ago. Yeah, that's not too surprising with those beastly HPs. And I have seen a few of those chasing out of Abilene into the San Angelo area. Kevin McKinney and Ahmed Tree Nelson. Jason Boggs wishes he was on that cell down in South Texas. Tom J. Derek Ketcherside. Ryan says those 60s dew points really pushed up fast today. Sarah Wood from Indiana checking in with 51 degrees there. Mike Estwick saying 40 degrees in Denver. Overcast in Columbus with Ryan there. Yeah, a little bit cool there in that part of the country with that northwesterly flow. 51 and clear where Joshua Gilbert is. 70 dew points creeping into South Texas. Ryan says, with the low staying stationary over the Four Corners, does that give it time to build up higher severe weather potential on Sunday? Yeah, slower moving systems are better for severe weather outbreaks, because if we have a fast moving progressive pattern with systems moving rapidly west to east, it's very difficult to build in a moisture return and bring in the really deep moisture off the Gulf. So we're actually getting more of a slow trickle of deep moisture coming up for tomorrow, and that's definitely helpful. Plus, that gives you multiple days of severe weather episodes. Justin Pulliam says, spotter confirmed large tornado on the ground on that San Angelo storm. Okay. Yeah, he says 8:12 p.m. Confirmed an extremely dangerous tornado located near Voss or 11 miles west of Coleman. All right, yeah, let's go back and check that out and see what's going on. Holy good grief, in 5-7 minutes it really pulled together here. So now we're seeing a very distinct Bear's cage right here, and let's check out what the velocities are doing now. They've intensified a little bit. I'm seeing 40 out. Yeah, the most I'm seeing is 40 out and 34 in, so some very strong, very broad rotation. And I'm not picking up anything here that looks like a TVS, but then again, we're some distance from the radar. We're about 53 miles away from the radar, so that's getting into marginal territory for picking up low-level structure on these storms. But what you can do is you can use time consistency. So I can roll backwards and maybe see if I saw any cycles of tornado spin up. Not seeing anything there, so probably maybe what's happening here is, I don't know, here's a spot right here of some pretty strong shear. 37 out and 17 in, that's about 50-60 knots of shear. And here I'm seeing about 30 knots of shear. So yeah, I'm not too sure. I think we may just be overshooting the strongest, tightest rotation there. Here's the mesocyclone aloft. Looks quite a bit stronger as we would expect. So we've got like 50 out and 30 in. That's about 80 knots of rotation there across 3 miles. And I'll set a dot right here in the center, and you can compare that there to the reflectivity. So I guess we've got some occlusion going on. The main meso back here kind of separated from the Bear's cage further out to the east. Okay, we'll head up to some higher tilts. I can see some much stronger inflow coming in right here. I'm sorry, that's outflow. I'm kind of messed up. Yeah, see, this is actually going from the radar. This is up at 10,000 feet here, so just ignore what I said there. But as we go aloft, we see, I guess, what's the older meso right here, and then a separate meso further back here. This may be more associated with that tornado circulation back here. That may be on the back side of the storm. Let me put a marker there, see where that is. Yeah, that's on the back side. So the newer cycles of mesocyclone development are going to be right out here. And we're seeing 73 out here and about 20 in, so that's getting close to the 100 knot range. Then we get up to the top of the storm and we see what looks like mostly just anvil top divergence. So we're seeing kind of this pattern here. Just kind of the anvil spreading apart. Now we'll go back down to the surface and see what's going on. And we can see shear starting to pick up right in this area here. The stronger gate-to-gate, the stronger small-scale shear seems like it's limited to about 40 knots, as far as I can tell with this radar. So this is really when your spotter reports are important. Then we'll take a look at spectrum width real quick, and this kind of outlines the storm inflow area here. So that kind of wedge shape right there. And that's feeding into the storm. Okay, so that's what's going on with our storm right there, south of Coleman. And I used to drive through this area a lot back in the 90s. This road right here went from San Antonio to Abilene. And during my days off, I would go down and visit family. And did a few good storm chases out in that region back then. Okay, let's move on and look at some more of our charts, and we'll come back to that in a little bit. This is the infrared imagery, and it's showing the thunderstorm activity. We've got some just north of Lake Texoma, north of Durant. You'll notice the anvil top temperatures are colder with that activity. And this is our isolated supercell down in the Ballinger area. And then further out to the west, you can see the cutoff low over the Santa Fe area of New Mexico. So this is a large barotropic low. It's spinning, and it is essentially an occlusion. The main baroclinic area, frontal zone, is out in this region. And the jet is kind of lying just on the north side of that area in this region right here. And then we go to our thickness chart, and this kind of gives us another picture where our frontal zones are. And we can see that there's a pretty good pool of cold air over New Mexico and eastern Colorado. And you remember yesterday we had that Pacific front moving out of New Mexico. It was moving eastward. So what we're seeing right now is the Pacific front making its way eastward and starting to mingle with the colder Canadian air coming out of Nebraska and the Dakotas there. So the synoptic scale picture dominated by this front right there. Then we'll take a look at the soundings real quick and see what we got going on. We don't have a very good proximity sounding for that San Angelo storm. This is really when it would be nice to have sounding coverage in the Austin area. But we'll look at Del Rio real quick and see what that shows. And you can see the very steep lapse rates there. Almost dry adiabatic from the surface up to 700 millibars here. So very strong heating near the ground and good lapse rate here. The main contribution here is from the upper level lift starting to approach this area. And I remember that we had a stronger cap here at Del Rio earlier today. And then we'll take a quick look at Fort Worth, since that's out ahead of this area of storms. And there we go. It looks like a little elevated cloud layer from about 4,000 to 8,000 feet. A little bit of a subsidence inversion above that. So looks like our environment right there around Fort Worth, we're capped, just weakly capped, and I'm sure the approach of those upper air dynamics are going to erode what's left of that mid-level warmth there. Now for that system out around Midland earlier today, I was going to put this up here. This shows the vorticity at 500 millibars, and there's a good wave moving across the Midland area. So the development of that surface low along that front through here was probably linked with that upper air wave right there. So we saw that come together as the afternoon went on, and that's what helped, it's probably what helped kick off that storm there in San Angelo. So let's take a quick look at the forecast before we go back and look at that storm. Okay, we're going to see the dynamics, the stronger upper level winds and the waves and everything. Those are going to move out to the I-35 area tomorrow. So we're going to see severe weather potential come up for the eastern half of Texas. Main upper level low will move out over the Dallas-Fort Worth area overnight. And this will quickly eject northeastward, and we'll find that in the Ohio River Valley for Monday's webcast. So if we put our trough right there and our ridge right there, we would expect to find maybe some sort of frontal system set up like that. So we're going to look for maybe something like that on the surface chart. Here comes the next wave coming in from Nevada. So that's going to reach Texas and the Panhandles on Wednesday, Tuesday going into Wednesday. And the track of that will be mostly in the Central Plains there. Then it looks like we get a period of a very strong northerly flow here, so probably pushing down some cold air. Ridge builds in, and you can see we're pretty much free of dynamics here in Texas. You notice no waves moving through until about Tuesday the 11th and 12th, then things start picking up, and our next wave comes into the picture around the 13th or 14th there. Okay, to look at the forecast on for tomorrow's severe weather outbreak. We could certainly spend all night looking at charts, but to make this kind of quick, I'm going to look at the NAM forecast. Okay, so I've backed this up to the current hour, and you can see that up there. There we go, 0Z. So the main Pacific front lying kind of like that right there. You can see it's supported by this thickness gradient on the backside. So overnight we're going to see that Pacific front move very slowly eastward. Almost quasi-stationary. So it looks like by morning it's going to be through the Dallas area, down to around Junction and Del Rio. A lot of the convective activity will be east of there. Then most of this activity here, this will be more of a stratiform type precip. And this is when things start coming together for East Texas. You can see the southerly gradient in place here. So that's bringing up moisture from the Gulf. Then we see heating start to kick in. Now this activity here is probably along the front. And it's any activity that's out ahead of it is what I'm going to be concerned about tomorrow afternoon. So this stuff it's showing here, that's certainly got a lot of potential to go severe. And then the stuff comes in from the west. This is along the cold front. And here the potential for severe weather is a little bit more questionable because big wedges of cool air, those tend to form squall lines. So we're probably going to see kind of a linear mode there, but if we do get any breaks, there could be some potential for rotating storms there. Then that moves into the Louisiana, Arkansas area overnight, and then Mississippi and Alabama, they have to deal with that during the day on Monday. And this is a quick look at the dew point on the NAM. Okay, the picture tomorrow at noon is going to look like that. You can see the cold front coming in from the northwest, from Dallas to Del Rio. And this is showing the backed wind profiles over East Texas, and that's going to help stretch out the photographs. We're going to see high storm relative helicity setting up in this area. That combined with these 70s dew points. So a lot of positive factors, and if I set this crosshair here and bring up the forecast sounding, this shows that a lot of our ingredients are looking pretty good here for severe weather. Cape is going to be kind of high. LCL is looking good. Storm relative helicity and bulk wind shear are looking especially favorable. And you can see the photograph right here. So look at that. You can see 40 knots, 40 knot flow. Winds out of the south-southeast at 40, contrasting with east-southeast winds of 15 at the surface. So that stretches out the first 1 kilometer of the photograph. And then we get a little bit of veering of the flow up to 2 kilometers. That stretches it out even more. So depending on which layer you go with, you're going to get a photograph you're going to get a helicity, storm relative helicity profile that's very swept out here. Okay, so let's see, back to our chart. We're going to advance this up to 0Z at the time of the forecast. So we've got the cold front from about Greenville through Corsicana and then down towards just east of Austin there. So probably some good storm potential in this area right here. And yeah, this is the storm significant tornado parameter. This is another thing you can look at. This summarizes all of your basic ingredients, your CAPE, your low LCLs, your high SRH, storm autophilicity, and your high bulk shear. So that kind of summarizes all of those. And we can see that at 21Z, 4 p.m., that's mostly concentrated from about Lufkin to just southeast of Dallas right there. And then we see the values are a little bit lower near the front. And I took a quick look at that earlier, and that appears to be mostly due to the veering of the wind profiles along that trough there. Okay, let me take a quick look at the chat. This is way too much for me to read, but I appreciate the discussion here. I'm going to go back to that storm here briefly. Got Jason and Derek and Ryan talking about the tornado, or the supercell out there in the San Angelo area. Mike asks, in digital atmosphere, how do you have it set up? How do you have your base map set up for the area? I just put it on wherever I'm looking at. Okay, there's another look at the webcam. I'm going to have to adjust those chroma key settings because it looks kind of like a mess there, but let's check out that storm there south of Coleman. Still definitely looks severe, and you can see that the stronger reflectivity gradients, they're kind of concentrated in this area here. And the structure that we're seeing here is kind of like that right there. So here we have the RFD. So we got that boundary here surging out south of the updraft. And this here is the forward flank downdraft right there. And then we have the updraft located right in this area here. And the Bear's Cage, this is basically in this rain-free base area here, right, where we have lower reflectivities. That doesn't mean it's exactly free of rain. You're going to have some rain and maybe even a little bit of hail falling in this area here, especially with an HP storm. But you'll probably get a good view into the region back here where the wall cloud is going to be developing. So we would be looking for that to be underway right in that area here. So I'm going to put a mark. We'll go to storm relative velocity, and we can see that's pretty well correlated with this high shear area. Now it does look like the values have gone down a bit. I'm seeing about 12 knots out and 34 in. It's only about 40 knots of shear in this area here. But as we've seen, the storm has been cycling, and we could certainly see another round of severe weather as that moves eastward. Then we'll take a look at what's going on aloft. That's kind of like what's going on under the hood. This is where we usually find the stronger circulations. So I think this is the older circulation back here, and I'm seeing like 30 out and about 20 to 30 in. And then we have the newer one right here. Then a quick look at spectrum width. This shows a little bit of the inflow and a little bit of the updraft right in this area. So that's corresponding to the low reflectivity region right there. So probably the best place to be if you're chasing the storm is probably about right here or right there. And you'll be looking into the storm right there. But of course you have this RFD moving towards you. So you have to get your timing just right if you want to move north and then get east. So you'd be contending with this core right here, and you'd have to be careful not to get stuck in this region right here, because you'd really get hammered by this as that moves through that region right there. Okay, we got one more scan here. We'll take a quick look. I don't have the reflective or the velocity in yet. but we do have the newer reflectivity. And, well, guys, I guess that's probably a good stopping point since we're about 40 minutes in. But what I'm going to do tomorrow is if we have a severe weather outbreak and we have supercells going on, I'll probably bring the channel up early and we'll take a look at some of those storms. So stay tuned and subscribe to the Twitter feed, and I'll probably try to transmit an update on there when I'm thinking about going live. Okay, I hope you all have a good evening there, and let me get the music going here so I can sign out. Okay, good, there we go. Anyway, I appreciate you all watching, and stay safe, and we'll see you tomorrow.